Hello everyone. This video is on the Knewton Alta assignment, section 3.1, part 3, called Difference Quotients. So in this video I'm going to be going through a preview version of this assignment. So please understand that the questions I'm seeing in this video may not be the same questions that you see when you work on the assignment yourself. But the objective will be the same, the questions should be similar, so I'm hoping that watching me here will help you in some way when you work on it on your own. Alright, so on your assignment page you have the title, you have the mastery bar, your objectives, which looks like there's only the one objective for this assignment. That's good. Then below the objective you have a question related to the objective. And at the bottom of every question you should see a feedback button where you can send feedback to Knewton if you wish. You will not have the instructor cheat button, but you will have a more instruction button. If you're struggling on a topic, try clicking on more instruction. It'll take you to some further reading, some videos, maybe both, and then some questions related to that instruction that you can work on and get through the assignment that way. Alright. So the objective for all the questions in this video is determine the difference quotient. So before we get into this problem here, I want to talk about real quick what the difference quotient of a function is. The difference quotient of a function. Alright, so say we're given a function, say y equals, f of x, a function called f, where the input's x, the output's f of x or y, whatever you want to call it. They're equivalent. And, it has a graph. And it's a function, so it should pass the vertical line test. I'm going to, just some random graph of a function here. Now, the difference quotient of a function just gives me the slope. This is the slope, a description of the slope of a line that goes going through any 2 points on that function. And really it is any 2 points on the function. That's all the difference quotient is. So how do you find the slope of a line? Alright, well first you need 2 points. So I'm going to pick, just any value called x, right? This is a variable. This could be anywhere, right? And that value of x, right, as long as it's in the domain, right, corresponds to a value of y, which if the function's called f, the output would be called f of x. Right? So here's a point, x comma f of x. And now I need another point on the curve, another point of the function. Well, that means we just move from x somewhere else. Say over here, it doesn't matter. Go over here, over here. Now this distance that's being moved, you could call it the change in x or the run. You could do delta x, but in this book, in this particular section, they're calling this h. So h is the change in x, it's the run. The horizontal change, right? So this other value over here we're calling x plus h then. It's, you know, the x that I started from plus the change in x. And that's another input. So it corresponds to some output from the, from the range. Right? And if the input's x plus h, the output would be called f of x plus h. Right? And so here's this point, input x plus h, output f of x plus h. Right? Now if I were to draw a line going through these 2 points, and remember these 2 points aren't just here and here, they could be anywhere. You know, if I change my value of x and h, they could be anywhere on the graph. So let me draw a line through these 2 points. I'll make it a dashed line because it's not actually part of the function. Here's a line. This is called a secant line. You're not going to need to know that, but it's just a line that cuts through 2 points on a graph. All right. The difference quotient of a function called f, or any function, is just the slope of this line I just drew. Now remember how slope goes. It's rise over run, change in y over change in x. So from, say this point here to this point here, the change in y would be f of x plus h minus f of x. Right? There's the change in the outputs. And then the change in the inputs, the change in x, the denominator would be x plus h minus x. But x plus h minus x would just be h. And notice that since we have h in a denominator here, we have to state that h can't be 0. Right? And hopefully that makes sense too, because if h were 0, if this change in x were nothing, there'd be one point and then only that point. Right? You wouldn't be able to form a line. Right? Okay. So this right here, what I'm putting in the box, is called the difference quotient of f. And all it does, again, is it just gives us the slope of any line, right? The slope of a line going through any 2 points of the function. You just pick a value of x, you pick a value of h, and it takes you to 2 different points on the curve, and you find the slope of the line going through those 2 points. Right. Now, I'm not going to be drawing any pictures here. Right, we're just going to calculate this difference quotient given whatever function we're given. And then, of course, it's a fraction. We're going to have to simplify that fraction as well. All right. So the first function we are given is this one. F of x equals negative, the opposite of x squared plus 2x plus 1. And we're asked to, compute the difference quotient. So remember, this is f at x. Now I just need to know what's f at x plus h. Right? When I move to the right or left h units, whatever h is. Hopefully you recall how function notation works from earlier in this section. A different part of this section, part 2 or part 1. Just go through and replace all the x's with the quantity x plus h. So instead of negative 1 times x squared, this is now negative 1 times the quantity x plus h squared, plus, and then 2 times, and then instead of x, it's the quantity x plus h. And then you still got the plus 1. All right. And what I'm going to do now is go through and simplify this. Right? So remember, you raise things to powers first. So this would be negative. Now be careful. X plus h squared is not x squared plus h squared. This is x plus h times x plus h again, and you FOIL. This would be x squared plus 2xh plus h squared. Right? You don't forget the plus, the middle term there. Then here I distribute the 2. We got plus 2x plus 2h. Then you still got the plus 1. And then finally, distributing the negative sign here, negative 1, we have negative x squared minus 2xh minus h squared plus 2x plus 2h plus 1, right? A lot of writing, I know. but it's necessary. All right, so now for the difference quotient, right? That slope, I'll just put diff quo. Right? It's the change in these outputs, right? F of x plus h minus f of x, all divided by the change in the inputs, x plus h minus x, but that would just be h. Okay, now what is f of x plus h? It was all this, right? It was negative x squared minus 2xh minus h squared plus 2x plus 2h plus 1. That is f of x plus h. Then we're subtracting all of f of x, right? So I'm going to put parentheses around what f of x is. Negative x squared plus 2x plus 1. And so, there's multiple terms here. We're subtracting all of it. Subtract all three of those terms. And then all that gets divided by h. And we have to simplify this fraction, right? I mean, this is the difference quotient. It's just you should be able to simplify. You should be able to eventually get rid of h in the denominator. Now, see negative x squared minus negative x squared, that's gone. You still have the negative 2xh. Still have the minus h squared. And you see positive 2x here, minus 2x. That's gone. Then you got the plus 2h. And then you got plus 1 here, minus 1 here. That's gone too. So all the terms that are left are terms with h in it, in the numerator. And then if I go through and divide each and every single one of these terms by h, or factor h out of the numerator and cancel it with the h in the denominator, this should simplify to negative 2x minus h plus 2. All right, when you divide every single term by h. And there you go. That is the simplified version of this difference quotient, this slope. And once again, this will just tell me the slope of any line going through any 2 points on the graph of this curve, right? The graph of this would be some parabola. All I would need to do is pick a value of x, pick a value of h, start at x, go to x plus h, plot those 2 points, draw a line. This will tell me the slope of that line. All right, but I'm not going to get in all that. All right, they just wanted this. So back here, negative 2x minus h plus 2, that's that very first one. There you go. Now after you submit it'll tell you if you got it right or wrong and give you some sort of answer explanation. Please read through the answer explanations, because hopefully you'll figure out why you were wrong and can learn and fix your mistakes in the future. Alright, so moving on. Same objective the entire time. Determine this difference quotient. Alright, so let me do the same thing again. Alright, so we're given another quadratic function. F of x equals x squared minus x plus 1. The value of f at x plus h would be, x plus h squared minus x plus h quantity, right? And then plus 1. So that would be x squared plus 2xh plus h squared, right? That's the quantity x plus h to the second power. Then distributing the negative here, we have minus x minus h plus 1. And then we're going to subtract these. Alright, I'm taking f of x plus h minus every term from f of x, and then this is getting divided by h. This is the difference quotient. So if you subtract, f of x plus h, and then subtract the terms, each term from f of x, the x squared will be gone, the negative x will be gone, the plus 1 will be gone, and I'll be left with 2xh plus h squared minus h in the numerator. Alright, and then h in the denominator, and then you actually divide through by h, giving me 2x plus h minus 1. And there we go. That's the simplified difference quotient. Okay. 2x plus h minus 1, that's the second option here. Hooray. Okay, moving on. And another quadratic. So let's do it again. So here we're given f of x equals -2 times x squared minus 3 times x plus 1. What's f at x plus h? And again, just replace all the x's with the quantity x plus h. -2 times the quantity x plus h squared minus 3 times the quantity x plus h. And then you got the plus 1 still. So this is -2 times the quantity. Now x plus h squared you've seen a couple times now. That's x squared plus 2xh plus h squared. Distribute the -3 here. You got minus 3x minus 3h, then plus 1. And then finally, distributing the -2, we have -2x squared minus 4xh minus 2h squared, and then the rest of it, minus 3x minus 3h plus 1. And then we're going to subtract all the terms from f of x from this, right? So we're taking f at x plus h minus the terms from f at x and dividing by h, right? This is the difference quotient. Now if I do this, the -2x squared would go, the -3x would go, and the positive 1 would go, right? They'd be subtracting to be 0. So all I'd be left with in the numerator is -4xh minus 2h squared minus 3h. And this all gets divided by h, and if you divide each of these by h, you'll have -4x minus 2h to the first, and then minus 3. Right, all those h's canceling, and there we go. That's the simplified version of the difference quotient. So -4x minus 2h minus 3. That's this last term here, this last expression here. Okay. Great. All right, and then one more. I'm hoping they don't give you quadratics all the time, but let's see. Yeah, so I'm getting a quadratic every single time here. Again, not always going to happen, but it might. Just be aware of how you're doing this. Take f at x plus h minus f at x, and then divide by h and try to simplify it, right? Try to get it so that h is gone in the denominator. Right. All right, so one more time. So we're given this quadratic function. F at x equals 2x squared plus x plus 2. What's f at x plus h? This would be 2 times now. I'll just do what x plus h squared is right now. That's x squared plus 2xh plus h squared plus, and then x becomes just x plus h, and there's really no need for parentheses. Nothing's going to be distributed or anything. Then plus 2. And distributing the 2, we got 2x squared plus 4xh plus 2h squared, and then the rest of it plus x plus h plus 2. Then you're subtracting the terms from f of x from this. All right, so the difference quotient, f at x plus h minus f at x, all divided by h. Numerator, we're taking this, f at x plus h, and subtracting all these. Well, the 2x squared would be gone, the x would be gone, and the 2 would be gone, and you're left with all these terms with h in it, right? 4xh plus 2h squared plus h divided by h. And if you divide each of these terms by h, or factor in h out of the numerator and cancel the h's, you'll have 4x plus 2h plus 1. There's the totally simplified version of that difference quotient. Oh, and you actually have to type it in. Okay, 4x plus 2h plus 1. Wonderful. Okay, and again, I know I kind of went through pretty quickly there, but Once you get the hang of these, they should all be pretty easy, especially if they're always a quadratic function. Should be pretty quick. And yeah, and that should be it for the preview version of this assignment. Like I said at the top of the video, the questions I saw here may not be the same questions you're going to see, but the objective is the same. So the way you would go about it, they're taking f at x plus h, subtracting f at x, and then dividing by h, right? That change in x, and simplifying. You're doing the same thing for all of these, right? No matter what the function looks like. And I hope watching me go through these examples here help you out, especially if you're looking at quadratic functions. Watching my examples here should definitely help you out. And yeah, and thank you very much for watching.